Good morning, everyone. Pre-calculus 2-2 polynomial functions. Okay, these are the topics we are going to cover. What are some characteristics of graph of a polynomial function? All continuous. Domain should be odd real number because it covers everywhere, keeps going to the left, keeps going to the right. So domain is odd real number. Range will be, I think the lowest point you go below one little bit here. So I would say maybe minus 0.5 and higher. So minus 0.5, comma infinity, and it will be inclusive for minus 0.5. We have a local maximum, local minimum here, and the behavior wise, as you go to the left, keep going up, keep going up. As you go to the right, keep going up, keep going up. So, and the behavior, if I ask you to write left and right, left it will be limit of f of x as x approaches to minus infinity goes up positive infinity. Right limit will be limit of f of x as x approaches to infinity will be positive infinity goes up. X-intercept, I have a 1, 2, 3 x-intercept here. Y-intercept will be only 1, which is 0. So I can talk about decreasing. It's decreasing right here up to here. Increasing, decreasing, and increasing. Okay, so example 1. Graph f of x equal to x minus 3 to the 5th power. So here's what you can do. If you look at this, x has a 5th power. Of course, this is x minus 3, x minus 3, x minus 3, x minus 3, x minus 3. You have to fold it, you have to fold it, you have to distribute. Distributing all this is going to take very long time. But all I'm trying to say is when you distribute, this times this times this times this times this will create x to the 5th power. And of course, there'll be some x to the 4th, x to the 3rd, and so forth. But highest power will be 5th power. X is here, 5th power. Highest power of x will be 5th power. So you do know this one will have a degree of a 5, which is odd power. Odd power, the both ends go opposite direction. And if you look at it, coefficient is, leading coefficient should be 1. Okay? If you distribute x, it's going to be x to the 5th power. That's the highest power. It has a coefficient as a 1 in front of it. So leading coefficient is positive. So right hand gotta go up, left hand gotta go down. Because highest power is a 5. Opposite direction. So we did this from last class period. So when I ask you to graph this, so basically you're looking at y equal to x to the 5th power, which should look something like this. And x minus 3 parenthesis 5th power, so we are going right by 3. So if you sketch it, it's going to look something like this. And right here, that's a 3. So you might say, well, can I just use a graphing calculator, type it in, and graph it? Yes, you can. But sometimes I will expect you to do this without graphing calculator. Okay? So you might say, how do you do that? You should know y equal to x to the 5th power looks like something like this. And all you have to do is move right by 3. So that's going to be a rough sketch of it. Okay, graph f of x equal to 2 plus x to the 3rd power. So x to the 5th power, x to the 3rd power, they share exactly similar structure of the shape. Odd power, meaning left hand, right hand will go opposite direction. One goes up, one goes down. One goes down, one goes up. Leading coefficient is 1. So right hand gotta go up, left hand gotta go down. The shape will be exactly same as this. Of course, it will be a little more like slimmer in a sense, or wider, but overall shape will be just similar to x to the fifth power. So plus 2, x cannot see 2, so you should go up by 2. Moving, shifting upward by 2. If it was x plus 2 parentheses cubic, then x can see 2, so it should be left by 2. X cannot see 2. So up by 2, overall sketch will be something like this. Again, you might say, well, can I just use graphing calculator? If you have calculator available, then yes. But I expect you to know how to do roughly sketch it without graphing calculator. So this is going to be review from last lesson. If you have a degree, even power, both ends go to same direction. If you have a degree, odd power, both ends go opposite direction. Leading coefficient positive means right hand goes up. Leading coefficient negative means right hand goes down. So we did this in last class. Describe the end behavior graph of the f of x equal to the following using the limits. Explain your reasoning leading term test. Okay, so what are they talking about here? First thing you want to look at is leading coefficient. Leading coefficient. Look at the highest power of x, x to the fourth power, the number in front of highest power of x, which is 3. Leading coefficient is 3, positive. What does that tell us? Right hand gonna go up. Now, next thing you need to look at is degree. Means highest power of x, 4. Degree is 4, which is even power. What does that tell you? Both ends will go same direction. So since we know right hand goes up, you know left hand gotta go up too. Okay? What can you say something between? That's out of our limitation here. Okay, we cannot figure out what's going on between, but we can tell what happened to the left hand, what happened to the right hand. Okay? So can it be something like this? That's possible. Can it be something like up and down like that? Yes, that's possible. Anything is possible. Okay? All we care is what happened to the left hand, what happened to the right hand. So left hand goes up, right hand goes up. So that's this is how you say. Left hand, limit of f of x as x approaches minus infinity, y goes up infinity. Right hand, x approaches positive infinity, goes up, which is positive infinity here. Same thing. So first thing you need to check is leading coefficient. Look at the highest power of x, number in front of it, minus 2. Minus means right hand gotta go down. Then you look at degree, highest power of x. It's a 5, which is odd power. What does that tell us? Odd power means opposite direction. Since you know right hand goes down, you should know left hand gotta go up. That's all we know. What happened between? That we don't know. That's all we need to know though. So left hand, x approach to minus infinity. Yeah, I got just like that. Okay, as x approaches to minus infinity, which means left, y goes up, which is positive infinity. Everything is okay. As you go to the right, which is x approaches to positive infinity, right hand, y goes down, which is minus infinity. So everything works good. You might say, well, can I just graph this using graphing calculator? So your graph will show you something like that. Then I can say end behavior. Yes, of course. But for this kind of a question, usually I ask you to do that without graphing calculator. Okay, zeros and turning points of polynomial functions. A polynomial function of degree n has at most n distinct real zeros and at most n-1 turning points. You might say, what? What are you talking about? Okay, if you have f of x equal to following, what's the highest power of x? Sixth power? We call that as a degree. Okay, so degree of this function is 6. Then you know you can have at most 6 real zeros. So you might say, what do you mean real zeros? X-intercept. At most, be careful. At most 6 means it doesn't have to have always 6. It can be reduced by 2. You can have 6, 4, 2. You can have nothing, yeah, 0. But at most you can have 6 real zeros. And turning point means like this. Turning. So that's a turning point, that's a turning point, that's a turning point. Local maximum, minimum will be the turning point. So turning point, we will have 1 less. So degree is 6, we have a 5, at most 5 turning point. Meaning maximum turning point you can have is 5. And can be reduced by 2. It can be 5, 3, 1, and that's it. Okay? So it's not that difficult. Okay, state the number of possible real zeros. Look at the highest power of x. 3. That's it. Possible real zeros, number of possible real zero is 3. The same as the degree. Turning point will be 1 less than degree. So possible number of turning point will be 2. Then determine all the real zeros by factoring. Okay, so now we are dealing with factoring. So if you look at x to the third plus 5x squared plus 4x, can you factor common factor? Is there a common factor? Yes, x goes here, x goes here, x goes here. So you can factor x out. So I had some students a little confused what I meant by factor x out. X cubic means x times x times x. Okay? So when I say factor x out means divide by x. Divide by x. So when you factor x out, left over will be x squared. That's why we have x squared. 5x squared, factoring x out means dividing by x. You got 5 times x divided by x. 1x cancels out, left over with 5x. 4x here, same thing. 4x factor out x means divide by x, end up with a 4. That's what I meant by take a GCF out, greatest common factor from here, x out, and that's this. Now you have to do trinomial factoring here. So the way you do trinomial factoring is, let me just, so maybe some of you can do that in your head. The inside here, x squared plus 5x plus 4, you can do factoring. What times what makes leading coefficient here? There's a nothing here, which means 1 is hiding. So two numbers, when you multiply, it becomes 1. Right? 1 times 1. Now you're thinking of two numbers, when you multiply them, it becomes 4. Well, there are several. 1 times 4, 2 times 2. Also, minus 1 times minus 4, minus 2 times minus 2. There are 4 different combinations. So you gotta choose one. So you get 1 and 4. When you multiply these two, you should match this. Then multiply cross 1 times 4. Multiply cross 1 times 1. Now you add this number, then it becomes 5. This number should match coefficient of x. These numbers should match. If it doesn't, you gotta try a different combination. Okay, once you have a matching numbers here, you found your combination. So throw x here, put a parenthesis. When you write the answer, please, you're writing answer top floor here, bottom floor here. Okay, don't write answer in cross. So x plus 1, x plus 4 on the bottom floor. That's how you factor from here to here. Then you are solving for x. This times this equal to 0. You can set each of them equal to 0. X equal to 0 here. X plus 4 equal to 0. X plus 1 equal to 0. Solve for x. This one is done. Minus 4 both sides. You got minus 4. Minus 1 both sides. You got minus 1. You got 1, 2, 3 zeros. So determine all the real zeros by factoring. We got it. 1, 2, 3 of them. Okay. Okay, please pause the video. Retry it. If you did try, you should have gotten this. Possible real zeros is highest power of x, 3. So I got possible number of zeros are 3. Possible number of turning point always 1 less than the degree, which is 2. And this is a work I did to solve real zeros. So take a look at it. If you got them, you're good. Quadratic form. So polynomial expression in x in quadratic form, if it's written as au squared plus bu plus c. So if you have square here, first power constant, then we call that as a quadratic form. Okay. So we do have an example here. They are trying to solve x to the 4th minus 5x squared minus 14. They are saying, if you look at this 4th power and 2nd power and 0th power, we can use substitution, u equal to x squared. So given problem is x to the 4th minus 5x squared minus 14. For 4th power, 2nd power, 0th power, in this setting, you could have used u equal to x squared. Okay? U equal to x squared. That means u squared equal to x to the 4th power. If you square left and right, it becomes u squared equal to x to the 4th. What does that mean? X to the 4th is same as u squared. X squared is u minus 5u minus 14. So you have this. By substituting x squared with u, you can rewrite that is into this. Then we can do trinomial factoring. 1 times 1 makes 1. Minus 14 has several. 1 times minus 14, 2 times minus 7, minus 1 times 14, minus 2 times 7. So we have a 4 different combination. You have to choose which one. 2n minus 7 is the one which is going to work. 2n minus 7, multiply, you get minus 7. Multiply, you get 2. Add them, you get minus 5. So these numbers are matching. So you can write that as u here, top floor, bottom floor. So u plus 2, u minus 7, u is x squared. So you can rewrite that as x squared plus 2, x squared minus 7. Okay? So we will try to get the 0 from there I just want you to show you a little taste of it. Okay? And we will use this technique for the following example.